Okay, so let's try this one. Disuruh kamu label asterisk simbol, yang simbol bintang ni, at chiral carbons kalau ada lah in each of the following molecules. So let's look at this A. Macam mana you nak tahu chiral carbon? Okay, chiral carbon kan is carbon sp3 attached to 4 different groups. So kalau kat sini, I believe that I think the chiral carbon yang you need to find is this carbon. Okay, so kita bawa keluar lah carbon ni. Okay, so dia kata chiral carbon ni adalah carbon sp3 attached to 4 different groups kan. So kat sini yang pertama Cl, yang kedua kita buatlah bond hydrogen. Okay. Dari mana pula hydrogen ni datang? Because carbon kena ada 4 covalent bond. So this is the first covalent bond, second, third. Therefore yang keempat ni adalah dengan hydrogen. So that's why bawa lah keluar hydrogen atom tu. Okay. And then kat sini dah ada first different group. Okay, so this yang pertama, yang kedua. And then kalau let's say if it is a cyclic compound, what do I tell you before this? You kena tengok lah dekat along the ring ni, dia ada perbezaan tak? I think tak ada. Kalau kat sini sama, it will be, this one will be CH2, CH2, CH2. Okay, kalau I go kat bawah pun, it will just be the same. CH2, CH2. Therefore memang tak ada langsung chiral carbon. So this carbon dia ada, this compound dia tiada chiral carbon. Okay. Next, how about this organic compound? Dia ada chiral carbon tak? Okay, so sekarang ni I nak keluarkan lah potential chiral carbon yang ada dekat this cyclic compound. So I'm going to keluarkan carbon in here. So this is the hydrogen atom. Also this carbon, because this will be the first group, second, and then the third, fourth. Okay, so I believe this carbon dia adalah chiral carbon, because kalau kita tengok ni, this is the first group, second, third, CH2, 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 fourth, CH2, C, Cl, CH. So kita go along the cyclic compound, the ring of the compound, we can see that dia ada different kat situ as we go along. So since that there are 4 different groups that attached to this carbon atom, so therefore I believe that this is a chiral carbon. Same goes to this one juga. This carbon dia attached to 1, 2. As I go along this ring, ada perbezaan kat sini, 3, 4. Okay. Ni CH2C, yang this one CH2, CH2, CH2C. Okay, so ada perbezaan kat situ. There's a point of difference there. So I believe that this carbon is also a chiral carbon. Okay, apa lagi? Mana lagi ada potential nak jadi chiral carbon? I think it's this one, because this will be the first group, CH. Okay, the second group ialah CH3. The third ialah OH. The fourth ialah this whole thing. So I believe these organic compounds are the total of 3 chiral centers. Okay. So the 3 chiral carbons. Okay, what happened kalau let's say ada 3 chiral carbons, you nak kena draw enantiomers ke? Tak perlu. Kalau let's say dia ada you boleh draw enantiomers kalau let's say dia ada satu chiral center dekat organic compound. Kalau ada more than one, you don't have to draw dia punya enantiomers, okay? Because it will be complicated and it's not covered in your syllabus yet. Alright? Okay, next, try this. Just look at identify chirality center in the molecule below. So as you can see here, macam mana you nak determine the chiral center? So you kena find, what you need to do is you need to find any potential chiral carbon. Okay, so macam mana nak cari potential chiral carbon kalau if it is not a cyclic compound? Okay, my hint is I would like you to look at carbon yang attached pada satu hydrogen atom. Okay, so this carbon boleh jadi potential chiral chiral center in this organic compound. Okay, macam if you look at this one, oh CH, so you boleh jadikan this carbon as carbon potential yang boleh jadi chiral carbon. How about this one? It will be this carbon. Kiranya kalau potential chiral carbon ni, if let's say if it's not a cyclic compound, you need to find carbon yang attached to only one hydrogen atom. So kalau contoh yang pertama ni, this carbon dia ada potential untuk jadi chiral carbon. So kita tengoklah groups yang attached to this carbon, dia ada berapa? Dia ada 4 lah. You kena buat as if ada 4 groups yang attached pada this carbon, tapi kita just nak tengok sama ada, is it a 4 different groups or 4 similar groups. Okay, so let's check it out. Alright, so I believe that this will be the first group. Okay, sebab satu hydrogen ni will usually jadi group yang pertama. Group kedua ialah functional group COOH. Okay, and then the third group ialah functional group OH. And the last thing ialah the fourth group ialah CH3. So this carbon atom dia memang attached to 4 different groups. That means this carbon atom is a chiral carbon. So that means in this molecule there is a chiral center just because this carbon is a chiral carbon. So kalau chiral carbon you nak bagi tahu this is a chiral carbon, how? You need to markkan dia dengan logo, dengan simbol asterisk, simbol bintang macam ni. Okay, next, if you look here, H ni will always be the first group. Okay, and then the next thing ialah kat sebelah ni BR. BR ni will be the second group. Okay, and then Cl the third group. And then CH3 ni adalah the fourth group. Again, this carbon atom they attached to 4 different groups, and therefore this carbon akan jadi chiral carbon. So bila organic molecule ni dia ada chiral carbon, that means dia ada chiral center lah dekat this molecule, dia boleh buat enantiomer. Okay, so let's look at the next one. Kita tengok this carbon, because this carbon mendekat pada this hydrogen, satu hydrogen atom, therefore this hydrogen atom akan jadi group yang pertama. Yang dalam kurungan CH2Cl ni akan jadi group yang kedua. This will be group yang ketiga, and CH3 akan jadi group yang keempat. Again, this carbon is attached to 4 different groups, so it will make this carbon as a chiral carbon. So this molecule pun dia ada chiral center. Okay, so that means ketiga-tiga molekul ni, since dia ada chiral carbon, so dia akan menyebabkan all of the molecules ada chiral center. Okay, chiral carbon dan chiral center ni sama saja. Okay, lepas tu kalau bila dia ada chiral center, maksudnya yang ni tambahan lah, tambahan info. Therefore all of these 3 compounds, these 3 organic compounds, all of them are optically active compounds. So bila dia adalah optically active compounds, makanya dia boleh buat enantiomers. Enantiomers ni apa? Sepasang isomers yang mirror image. Okay, so let's try these 3. Dia suruh kamu label asterisk ada chiral carbons ataupun chiral center in each of the following molecules, and if let's say dia ada chiral carbon, please draw the enantiomers too. Okay, so as usual, untuk kamu detect sama ada chiral carbon ke tidak, okay, my tips is you cari carbon yang sebelah tu ada satu saja hydrogen atom. Okay, macam ni. Kalau yang A ni, the potential chiral carbon here ialah this carbon. Okay, kalau B pula, oh, ada few carbon yang attached pada satu hydrogen atom, which is this one and this one. So that means ada 2 carbon yang potentially boleh ada chiral center. Okay, How about this one? It will be this carbon atom. Okay. Kalau D, it will be this carbon atom. Okay. Alright, so let's look at the solution here. Yang A tu, dia suruh kamu determine sama ada dia ada chiral center ke tidak kan. So once you dah tahu dia ada chiral center ke tidak, that means it is an optically active compound. So you kena draw dia punya enantiomers because the soalan wants you to draw the enantiomers. Okay, so you will only stop until you draw the enantiomers. So if you look at this organic compound, macam mana you nak determine dia punya chiral center ataupun chiral carbon, you cari carbon yang sebelah tu ada single hydrogen atom. So this carbon can be a potential chiral carbon. Okay, so I'm gonna highlight this one. Okay, lepas tu kita tengoklah group. Kita kena make sure this carbon ada 4 different groups. So how can you do it? H ni akan jadi the first group as usual. Okay, lepas tu OH akan jadi second group, CH3 third group, CH2 CH3 will be the fourth group. Okay, so that means this carbon is a chiral carbon. So kalau dia chiral carbon, what can you do is you can mark it dengan asterisk symbol macam ni ya, to show that it's a chiral carbon. So kalau dia chiral carbon, that means this compound dia ada chiral center, dia optically active compound, dia boleh draw enantiomers. So how can you draw it out? First thing first, I want you to translate the chiral carbon dalam bentuk macam ni. Carbon sp3 yang ada 4 sigma bonds. Lepas tu ada 4 different groups yang attached to it. Tak kisahlah letak OH atas, H bawah ke, tapi kena 4 different groups attached to it. Okay, after that, ni kan kita dah go through before this. I think soalan ni sama macam soalan try this yang previously. So that's why I'm going to do it faster. Okay, after that, untuk draw enantiomers, okay, baru you translatekan dia dalam bentuk tetrahedral 3D shape. Okay, di mana carbon ni you buatlah tetrahedral 3D shape tu, buat bentuk payung terbalik, lepas tu kena ada wedges bond dengan hedges bond. Lepas tu you letaklah all of these 4 different groups dekat all of these bonds. Okay, CH3, HOH, CH2, CH3. Macam in this case, I letak CH2, CH3 kat bawah, tapi make sure this bond kena attach pada this carbon CH2. Okay, and then untuk draw enantiomers, you kena remember enantiomers ialah sepasang isomer yang mirror image. And the next, you kena draw this line to show that this is a mirror. Okay, ni contohnya ni adalah mirror. Lepas tu you draw the mirror image of this structure yang you dah buat kat sini. So it will look something like this. Okay, 1, 2, 3, 4, and then tengok H kat sini, H kat sini, OH, OH. Lepas tu kalau kat sini you letak CH2, CH3, sini pun kena CH2, CH3, kat atas ni CH3. Okay, itu je lah yang pentingnya, kedudukan groups tersebut. Lepas tu dia punya how you draw dia punya tetrahedral 3D shape if let's say this is ada mirror kat sini. Okay, ni lah pantulan dia, itu yang paling penting lah. Okay, and then next what you need to do ialah you need to buat bracket macam ni, lepas tu you tulis enantiomers. Okay, barulah markah tu jadi lengkap. Okay. Okay, next, untuk B ni, this organic compound sangat panjang. Untuk tentukan dia punya chiral center ada ke tidak ada kat this organic compound, you kena cari carbon yang attach pada satu je hydrogen atom. Okay, you kena cari a potential chiral carbon. Macam nak cari potential chiral carbon? Carbon yang attach pada satu saja hydrogen atom. Therefore, kita highlightkan lah mana carbon yang attach pada satu saja hydrogen atom, which is ada 2 kat sini. So, you kena tentukan sama ada this carbon adalah chiral carbon ke tidak. So, you lukislah macam ni. Okay? Bila you lukis macam ni, you boleh tengok dengan lebih senang lah. So, let's tentukan this carbon, adakah this carbon chiral carbon ke tidak. So kita tengoklah 4 different groups yang attached to this carbon. This is the first one, this is the second one, this is the third one, and this is the fourth one. That means this carbon adalah chiral carbon. So kalau dia chiral carbon, what can you do is you need to mark, letak simbol asterisk begini. Okay. So next let's look at this carbon atom pula. Is this carbon atom is a chiral carbon or not? So let's check it out. Kita tengoklah 4 different groups yang attached to this carbon. 4 groups yang attached to this carbon, is it different or not? So this is the first group, this will be the second, this will be the third, and this will be the fourth. Okay, so 4 different groups ke? Yes, 4 different groups juga yang attached to this carbon atom. Therefore, it will be this carbon atom will be a chiral carbon. Okay. So kat sini untuk this organic compound, dia ada 2 chiral centers. So kalau dia ada 2 chiral centers, do we need to do the enantiomers? No, we don't need to do the enantiomers. Kenapa tak perlu buat? Because it's not in your syllabus yet. Bila ada 2 chiral center nak kena buat enantiomers. So far, kalau let's say you jumpa 1 chiral center, barulah you kena buat enantiomers. Okay? And then next, if you look at this organic compound, the potential chiral carbon yang you boleh jumpa ialah this carbon atom. Okay? Because dia directly attached pada satu saja hydrogen atom. So, how can we determine this carbon atom is a chiral carbon or not? So, let's check it out. This hydrogen will be the first group yang attached to this carbon atom. The second group ialah CH3. The third ialah CH2CH3. The fourth ialah CH3. Okay. Kalau you tak nampak, you boleh translatekan dia dalam bentuk macam ni first. Okay, lepas tu you isilah H, CH3, CH2, CH3 and CH3. So, adakah ada 4 different groups that attached to this carbon atom? Tidak. Because as you can see here, ada 2 benda yang sama kat sini, CH3 dengan CH3. So, therefore, this carbon, dia bukanlah chiral carbon. So, this organic compound tiada chiral center. Okay? No chirality center. Alright, so let's look at this organic compound. Dia ada chiral center ke tidak? So kita cari dulu carbon yang ada potential untuk jadi chiral carbon, which is this carbon atom, just because dia attached pada satu saja hydrogen. Okay, so untuk tentukan sama ada dia chiral carbon ke tidak, dia kena attach to 4 different groups. Alright, so now let's check it out. So this hydrogen will be the first one, the first group. Br jadi second, CH2, CH3 group yang ketiga, CH3 group yang keempat. So if we look here, keempat-empat group ni adalah berbeza. So therefore, dia akan menjadikan this carbon sebagai chiral carbon. So ada chiral center dekat this organic compound. So that means you need to draw, ada satu pula tu chiral center. So that means you need to draw enantiomers for this organic compound. Okay, so how can you draw it? First thing first, I will let you translate this organic compound dalam bentuk carbon sp3 macam ni. Lepas tu you isilah keempat-empat groups yang different ni dekat keempat-empat bond ni ya. So the first one, kita letaklah hydrogen, tak kisah nak letak hydrogen kat mana-mana. Okay, lepas tu second one Br, the third one is CH2CH3, and the fourth one is CH3. Okay, and please don't forget to mention this carbon is a chiral carbon by putting this symbol. Okay, because kalau let's say the question wants you to draw enantiomers, you need to show yang this is a chiral carbon by showing this symbol. Okay, nanti examiners tahulah nak marking. Okay, next ialah untuk lukis enantiomers, you have to make sure you kena lukis carbon sp3 yang tetrahedral, lepas tu dalam bentuk 3D di mana ada wedges bond dan juga hedges bond. Okay, you lukis, you draw something like this first. Okay, and then next you isi bond ni dengan groups yang you have decided here. Okay, so and then tapi kalau you nak macam cepat sikit, you buat je mirror ni dulu, lepas tu you lukis reflection of this structure. Okay, di mana carbon kat sini, and then this is the wedges bond, hedges bond. Okay, wedges, hedges. Lepas tu ada dua stick bond macam ni saja. Okay, lepas tu okay, I nak letak CH2, CH3 kat sini lah. Therefore kat sini pun I kena letak CH2, CH3. I just buat reflection of this CH2, CH3. Okay, make sure kat hujung kena H3. Jangan pula, sebab common mistake for student, diorang suka letak CH3, CH2, which is so wrong. Okay, H3 mesti kena dekat luar, dekat hujung sekali. Sebab kalau you letak CH3 dekat tengah-tengah ni, it is as if this carbon ada 5 covalent bond, so dia tak valid, dia jadi salah. Okay, so you make sure, be careful with that. Okay, you need to make sure H3 ni dekat belakang. Alright, itulah cabaran dia bila you kena lukis reflection, okay, for this CH2, CH3 ni. Okay, and then next kita letak BR lah dekat wedges bond ni, so tak ada apa-apa lah. Dekat sini BR, sini BR. Okay, you bayangkan you ada mirror, so you lukis reflection dia macam tu. And then next CH3, lepas tu H. Okay, tak kisah you susun macam mana sekalipun, as long as yang this one, this isomer ni, pasangan dia ni, you kena make sure dia mirror to this one. Okay, itu je. Okay, and then next yang mirror ni wajib lah you kena letak. Lepas tu dah you ada sepasang isomer yang mirror image to each other, jangan lupa mention that dua benda ni adalah enantiomers. Okay, so itu je. Okay guys, so let's recall this together. To summarize everything, isomers ni terbahagi kepada dua, constitutional isomers ataupun structural isomers and stereoisomers. Okay, kalau constitutional atau structural isomers, dia punya molecular formula dia sama. Okay, molecular formula sama, cuma yang different adalah structural formula. Okay, lepas tu constitutional atau structural isomers ni dia terbagi pada tiga pula, sama ada chain, positional ataupun functional group isomers. Okay, kalau chain isomers, dia punya structure tu akan berbeza dari segi carbon chain. Okay, carbon parent chain dia. You ingatlah C untuk carbon. Okay, next, kalau positional isomers, that means dia punya structural formula itu akan berubah dalam segi kedudukan functional group dia. Functional group tu akan berubah kedudukan. Itulah maksudnya positional isomers. Kalau functional group isomers pula, this one you kena remember lah, table yang ada bagi dekat functional group isomers tu. Kalau let's say alkene, you nak buat functional group isomers, pasangan dia ialah cycloalkene. Kalau aldehyde dengan ketone. Okay, itu something yang you need to remember. Alright, next ialah stereoisomers, which we have learned just now. Dia terbagi pada dua, diastereomers and enantiomers. Kalau diastereomers ialah cis-trans isomers, dia adalah non-mirror images. Okay, non-mirror images isomers. Kalau cis-trans isomers, dia ada dua dia punya syarat dia, which is yang paling penting, dia kena ada restricted rotation dekat carbon-carbon double bond ataupun dekat carbon single bond. Carbon-carbon single bond tapi is a cyclic compound lah. Okay, and then next ialah enantiomers. Enantiomers ni adalah optical isomerism. Okay, dia pun ada syarat-syarat dia. Syarat-syarat dia kenalah compound, organic compound tersebut mestilah optically active. Okay, that means dia kena ada chiral carbon ataupun chiral center. And then bila you nak draw enantiomers, you kena bayangkan you ada sepasang isomers yang mirror image to each other. Okay, untuk after dah melepas syarat ni baru you boleh dapat enantiomers yang isomers tu mirror image to each other. So that's all untuk subtopic 4.3. Thank you for watching, guys.